Hello, grade 8 mathematician. Welcome to this lesson on construction of geometric figures. Specifically, we're looking at bisecting lines using a compass and a straight edge. Now, before we proceed, the important note. Understanding and mastering geometric construction is crucial, not only for enjoying the various applications of geometry, but also for achieving proficiency in Euclidean geometry. Engaging in these constructions helps to significantly enhance logical thinking skills, which are foundational to the study of mathematics as a whole. This logical reasoning enables individuals to approach mathematical problems methodically and develop effective problem-solving techniques essential in various professional fields. For example, in engineering, precise geometric understanding is vital for designing structures and systems. In medicine, medical imaging and spatial awareness are enhanced by geometric principles. Thus, the practice of geometry constructions not only enriches one's mathematical education, but also cultivates skills that are highly sought after in diverse career paths such as architecture, physics, and technology, ultimately preparing students for real-world challenges. So, have you ever wondered how engineers, architects, or even sports field designers ensure everything is perfectly balanced? An example, balance scissors, symmetrical bridge semicircles, divided sports field. Now, how do professionals ensure this perfect balance? In geometry, we have incredible tools and techniques to achieve this precision. Today, we are going to unlock one of these essential skills, bisecting lines. Let us take a quick trip back to grade 7. You learned how to use a ruler to measure a line segment and find its midpoints, right? For example, if you had a line that was 6 centimeters long, where will its midpoints be? At 3 centimeters. What if we need to be incredibly precise beyond what the ruler alone can give us? What if the line isn't a neat whole number? That's when our trusty compass and a straight edge becomes our friend. Before we dive into the how to do, let's quickly refresh some important terms or vocabulary that we'll be using. So, now, first, a line segment is simply a part of a line that has two definite endpoints, like line AB, which we have seen on the previous line. To bisect a line segment means to cut it into two perfectly equal parts. Imagine you sharing a chocolate bar equally with a friend. You bisect it. The point where we cut it exactly in half is called the midpoint. So as we go on with our lesson, we will now see this other important vocabulary play important part, more especially because we are dealing with the perpendicular bisector, perpendicular lines, compass, straight edge, arc, radius, and probably in grade 6, when in your second, if you did, you should have encountered this term radius. Now, what is a perpendicular bisector? So, when we use a compass and a straight edge to bisect a line segment, we actually create something even more powerful, a perpendicular bisector. Remember from grade 7, perpendicular lines intersect, meet at a perfect 90-degree angle. A perpendicular bisector not only cuts the line in half, finding its midpoint, but it also crosses or intersects that line at a perfect right angle. So in actual fact, it's a 2-in-1 construction. The tools that we will need today, it's a compass and a straight edge. You have learned a compass as in grade 6 that it has to draw perfect circles or parts of circles called arcs. And a straight edge is just the ruler. And we'll also need a pencil and a paper or a geometry software, which is what I will be using also today. Now, okay, all right, let us put our knowledge into practice with a step-by-step example. We are going to bisect line AB, and now I'm just going to leave the slideshow a bit and proceed to the MathsPad. This is the software that I'll be using today, the MathsPad, which it's a free version of the MathsPad. You can get this at www.mathspad.co.uk. The free version, which has these tools that you see, is also a paid version, which is more than this, and you can do a lot more. But for this lesson, we'll just stick to this tool. Now, we are going to construct step by step or bisect the line segment AB. First, using our straight edge tool in our software or on your paper if you have, we have to draw a line segment. Now, a straight edge from our software is this, and we are going to draw a perfect line segment to that point. And once we have drawn our line segment, then we can name these two endpoints A. So we have our line AB. The objective is to construct two. We need to pick our compass tool, and we place the sharpest point. This is our compass tool. Look at it, it looks similar to the compass tool that you should be having in your math sets. We take our compass point, we firmly put the sharpest point at point A. And now this is crucial. We adjust the width, that is the distance between the sharpest point and where our pencil point, to slightly above half line A, the length of the line segment AB. Because if it is too short, the arcs or your arcs won't cross and the construction won't work. This is because the arcs won't be far enough apart to intersect. So we need them to overlap sufficiently to clear to intersection points. Now we need to draw from point A those arcs. Now the other important thing, we need to keep this, and I will also just adding that this also, that distance where the width that we're looking at, it's also the radius of a circle with center A. So in actual fact, when we do those arcs, we are constructing our circle, but we are only interested in that part of a circle which we call it arc. Something I have to do first, as you do these constructions, there are certain things, and so we construct these arcs. What I was doing was changing the width of my lines, so that those who are familiar with drawing, you'll be aware that there are different types of lines when you're constructing. But you'll also, if you be doing technical drawing, you will understand it. So we draw one arc above the line segment AB and below the line segment AB, and our arcs must be big, lengthy enough so that they will intersect. Now, step 3, we are going to again now move this sharpest point to point B, and we put our sharpest point there so that we draw the arc below the line segment And we make sure these arcs extend a good distance they need to intersect. So we draw these two arcs, one above line segment AB. Remember, I have locked the width of this distance, so the radius is the same. Again, also here we are drawing part of a circle with center B, so with the same radius as we were drawing those arcs. We have our two arcs, and we have used our straight edge and a compass to draw them. So the next step, we just need to label this point. Let's label this point, but before I label, let me quickly change. Okay, and let's label point this to be point C and this to be point D, the intersection point. My C looks quite like a C, and that is point D. So step, we need to take our straight edge and we draw a perfect straight line. We join these 2 points CD. Just have to ensure that it's perfectly straight so that we will not struggle to make this, to join these 2 points. And so you need to ensure, and this is similar to when you're doing it using pen and paper with this straight edge, and then we can take our pencil again and join these 2 points. So let's see if we perfectly. Again, let me just change to a thin construction line. It crosses the perfect. Now our line passes through point A and point B. Sorry, it crosses at C and D. We have constructed our perpendicular bisector CD. So why do we call it a perpendicular bisector? Line CD is a perpendicular bisector of AP. If you look closely, you can see it cuts exactly in half at its midpoint. So we can name that midpoint, which you can label F. You can label the midpoint F. Okay, let me quickly change the thickness there, and we label this point here F. Looks like F, the perfect F. So now line CD cuts line segment AB at F, and also it bisects line segment AB at point F, such that the expectation is that angle AFC will be 90 degrees. Remember, let's recall, perpendicular lines intersect at the point, and at that point the angle that is formed is 90 degrees. We can confidently claim or say that CD is a perpendicular bisector of AB. We can add small tick marks. Usually this is what happens to show that this line, this segment here, AF, is exactly or congruent, equals to that line segment FP. And we can even also show that this angle, this is a symbol to show that is 90 degrees. In other words, CF, angle CFP, it equals to 90 degrees, or segment CF is perpendicular to a line segment AP. Now, if we were to use the angle measuring tools in our software, you will find that the angle where CD cross AP is exactly 90 degrees, a perfect right angle. And I'm going to use that if, that protractor, I can rotate it. You can actually see that it's so difficult to move this. We are trying to measure that line that is going up there. You can actually see that it crosses at 90 degrees using our protractor. As for that distance, we can try to use our straight edge that is marked to try and show that that will be perfect And you can see also that F there, it's right in the middle of 8 units. So at that point, AB is 8 units, therefore AF is 4 units and FB is 4 units. Okay, that is how we have constructed a perpendicular bisector a perpendicular bisector of line segment FB, which is CD. And I can actually make that. Okay, it's your turn. Let's see if you can put this into practice. If you have, grab your own paper, a sharp pencil, your compass, and a straight edge. If you're using a digital tools, open your own MathPad or other geometry other software, and I'm just going to demonstrate now using Geometry Sketchpad. Okay, that's basic. And you need to draw a new line segment. Make this 7 centimeter long, or you can draw any line segment as you wish and call its endpoints X and Y. Or you can pause the video here and challenge yourself to bisect that line segment XY using the 5 steps we just learned. Remember those crucial tips. Compass opening, that is the radius, must be more than half the line, and absolutely no changing the compass width of the radius after you set it. Take your time, be precise. I know you might be, or you have actually, let us revise back. Let us revise again how we have actually done that. So we need to draw a line segment XY with our straight edge. So this time I've changed, I'm now using a Geometry Sketchpad to construct this. A Geometry Sketchpad works different from the MathPad. The MathPad, which this one, it's only online, and this free version, you can only use it online, and it's available at www.mathpad.co.uk. And this Geometry Sketchpad, I think it is also available, but you need to download it and run it in either your smartphone, Android, or you can run it on Windows or even Apple Macintosh. Okay, without further waste of time, let us just continue with this. So we needed to draw a clean line segment, and so I'm using this segment straight edge. This is a straight edge tool. As I've explained, this is operates differently from the MathPad. Now with this, I'll try to be as quick as possible because most of the resources I can show the label here, but remember we said we draw line X, Y, and I'll just make a show of here because I can quickly change that to X, and I can also show that label point, and also the label there to Y. Okay, so we have line segment XY. Now we need to take a compass point and we place the sharpest point. Now the compass on Geometry Sketchpad is not. Remember, a compass helps you to draw a circle. So the Geometry Sketchpad compass tool is actually, that circle. And so we put with the cursor there, the compass point there, and we draw a circle. But remember, we say this must be more than half the width of that, more than half the length of that circle. Perhaps, maybe let me reduce, and I'll explain why. I'm reducing that. But maybe before doing that, we said we need to draw a line segment that is 7 centimeters, and let us try and get the measure. Remember the other time we use, or this line is about 16.24 centimeters, and we only need 7, and so I can make it smaller until it reaches 7. If you look there, the measure of line Y, line segment XY. I'm changing the measurement, and as I'm moving the point, you can see it changes to, we know that it is now a perfect 7 centimeter. Now we need to draw, using our compass point, the arc. So we put the sharpest point there. So what we need is a line, is an arc, or we need to open our compass point more than half the length of more than half of this length, the length of x1. So what we are going to do strategically, we are going to put the cursor there up, and we will try and construct this circle, but I'm going to take the whole length of xy, and the reason is that it is more than half the distance of xy. And also using geometry sketchpad, it will help me to remember, because now I will actually need to do other construction in a different way, but I'm now doing it manually in terms of that construction. And so I know I don't have, after making the arcs, which will be there, I don't need, I must not change the radius, okay, or the width of between the sharpest point and the pencil point where I'm making those arcs. And I'm going to construct another circle now, starting at taking y as the center. The first time x was the center. Now I'm going to take y as the center. Okay, just want to deselect that. Now I'm going to take y as the center, and I'm going to construct the same circle using now that as the center. So these two circles are equal in radius, and so they are equal circles, these two. Remember, when we use there to draw that arcs, we took A as the center, and to draw also that arcs, we took B the same as the center, and the radius to draw those arcs is the same. So same thing also this side. Instead of drawing arcs here, we draw full circles, because an arc is part of a circle again. So, and I will encourage you as a habit to continue drawing, full circles instead of arcs, because it's one and the same thing, and you will see the reason as you learn your geometry, importance of drawing those as full circles. Now we need to find those intersection points. I can take that point tool and do that, but now I'm just going to go there and construct intersection point. So the points that we are interested at, it is that, and we can label those points as we did the other side. For completeness sake, let us just show that label. We can show that as label H, and also we can label that point there as I. So now the next, we join HI. Right? Joining HI, I can construct a segment, or I can use that segment edge and just draw. Remember, you take your straight edge or your ruler to join those 2 points. But with Geometry Sketchpad, it is simple. I can go and construct a segment between those 2 points, or joining those 2 points. I can construct a line, or I can construct a segment joining those 2 points, HI. So we have HI, and now HI bisects XY. We can also look for the intersection point there. We can construct the intersection. Recall the terminology or vocabulary that we explored earlier. Okay, now we can label that point and label it J, or whatever that you call it. So there it is. HI is a perpendicular bisector of xj. But how do we know? So we can use measuring tools that have here in Geometer Sketchpad. First, we can show that these two measures, xj and jy, a and jy, are equal. So we are going to measure the distance between x and j, and that distance is 3.5 centimeters. And we also measure, we expect the distance to be that. Let's see. Why? The distances are the same, 3.5. Then definitely HI has bisected X. HI has bisected XY at J. Now, we need to see if they are at perpendicular. Now, at that point, we need to determine whether it is actually 90 degrees. In other words, angle XJH must be 90 degrees. Angle YJH also be 90 degrees, because we have constructed a perpendicular bisector of XY. And at the point of intersection, that angle must be 90. Now let's measure that angle, XJA, using our things. Angle XJ, the measure of angle XJ is 90 degrees. And you can actually also conclude, or you can measure angle YJA, angle YJH. We expect also to be, voila, 90 degrees. So there you are. We have constructed a perpendicular bisector of line segment XY. So you can actually see that these two circles are equal because their radiuses are, the radii or radiuses are the same. So if you did your thing correctly, so you will find that your line segment is perfectly bisected and its midpoint should be exactly at 3.5 centimeters. I hope you did that very well. If you did not get it, it's not a train smash. So if it wasn't perfect this time, that's completely fine. Doing geometry takes practice, and every attempt makes you better. The same as what one is doing here with these two things. One had to practice long and years until some of these things become second nature, at your fingertips. Right, now we need to conclude where we learned. So what powerful skills did we master today? Hopefully, we learned how to bisect any given line segment, meaning cutting it in two perfectly equal parts, using just a compass and a straight edge. And even better, this construction also gives us a perpendicular bisector. That is a line that not only finds the midpoints but also crosses the original line at 90 degrees. Remember, the magic truly happens with precision, clean lines and clearer results. Always use a sharp pencil for clear marks, and never change your compass width or radius once you've set it for the initial lines. This foundational skill of constructing perpendicular bisectors is incredibly important. It's a building for many more complex geometric constructions that you will encounter in mathematics, and hopefully even in the next lesson. Takeaway: to solidify your understanding, here are a couple of tasks that you can try at home. Try bisecting 5 centimeter and 8 centimeter lines, and practice constructing its perpendicular bisectors. And also, can you think of any other real life situations beyond what we discussed where bisecting a line or creating a perpendicular bisector would be incredibly useful? Perhaps in art or carpentry or even cooking. Okay, this marks the end of our lesson. See you in the next lesson. Thank you for listening.